Hey everybody, welcome back. In this video, we're going to start chapter 5 and talk about the normal distribution. So just a quick reminder, a couple quick reminders on the difference between a sample and a population. Remember, a sample, it's any subset of our population, right? So our population is everything that we're interested in or that we want to know about. Our population could be all of the students at Valencia, right? And a sample of that population could be our class specifically, right? Our class is a subset of um, all the students at Valencia. Another reminder over here in this table, when we talk about samples, we're talking about statistics and things we talked about so far are the mean and the variance, as well as the standard deviation, right? We haven't talked about proportions yet. We'll get there. But just remember for our samples, our sample mean or our sample average is the X bar. The variance and the standard deviation are S of X squared or just S of X, and the proportion is P hat. And then when we're talking about a population, we're talking about parameters. So our population parameters for the mean is this Greek squiggly mu is what it's called. The variance is this other little squiggly guy. It's called sigma squared. And then the standard deviation is simply sigma. And our population proportion is P with no hat on it. Okay. All right, so let's talk about properties of a normal distribution. It can be kind of written out in shorthand. We can say some variable X, right? Some thing. Imagine this could be heights of humans, right? Or it could be the age of humans. It could be SAT scores or any other sort of test score you can think of, right? Any variable you can think of, heart rate, things like that. So those things, right? Heart rates can follow a normal distribution with a certain mean, right? Population mean. So we're talking about all heart rates. You know, maybe it's all heart rates in the world. Maybe it's just all heart rates in Orlando, Florida. All heart rates of patients at a certain hospital, right? And a certain variance or standard deviation. But again, just note these are about populations, right? So when we're talking about normal distributions, in chapter 5, we're talking about populations. So the normal distribution is symmetric, right? So if you remember from a few videos ago in chapter 3, when we talked about symmetric histograms or symmetric distributions, this means that our mean is the same as our median, which means our mean is at the center, right? Because the median is the number that cuts your data set in half, right? So you would expect the median to be exactly in the halfway point of your data, right? So the mean is approximately equal to the median. It's not going to be exactly the same, but it'll be close to the median, right? So our mean, we can assume, is at the center of our normal distribution. It's unimodal, right? It only has one hump. The mathematical model, which is shown to the right, has the x-axis as its horizontal asymptote. And so all that means is that this line never touches the x-axis, right? So if this is our x-axis, this is y. This is where x is equal to 0. This line just goes on and on and on forever to infinity, right? In the negative direction and the positive direction this way as well, without ever touching 0. And then lastly, this is really key. The area under our normal curve is equal to 1. This corresponds to 100% of our data falling below the curve, right? So this curve is going to capture our entire population. And so basically the area under it equals 1. All right, so the mean of the normal distribution determines where the peak of the curve is centered, right? The mean is at the center. Because this is unimodal, it's only got one peak. So wherever the mean is also where your peak is going to be. So you can see here on this graph, we have 3 different normal distributions, right? They have 3 different means, which is what our M here is. So this first blue normal distribution has a mean of 900, which is why if we come down from the peak, right, we come to 900. So we would see that the mean is 900, right? Increasing your mean can move the curve to the right, right? It just kind of slides this curve over. If we increase our mean to 1100 with this green line, you can see the curve, the width of the curve looks the same, right? But now instead of being centered around 900, it's now centered around 1100, right? It's just slid over to the right. And furthermore, we increase it again to 1300, right? It slides to the right even farther. And now it's centered around 1300. And then conversely, right, if we were to decrease it from 1300 back down to 1100, it would slide then to the left. Right, so what's important to note here is there isn't just one normal distribution, right? You can have many different normal distributions, right? That have different means and also different standard deviations. So we saw in the last slide, changing the mean slides your distribution from left to right along your x-axis. And the standard deviation stretches or squeezes the curve. So a small standard deviation will have a narrow curve. This is because if you have a small standard deviation or small variability, your data is closer together, right? So it's less variable, it's less spread out or dispersed. So it's closer together. You can see the standard deviation is equal to 80, right? The blue line has the highest peak, and it's also the skinniest curve. Then if we increase our standard deviation to 120, that peak gets a little smaller. And what happens to our tails? Our tails get a little bit wider, right? Our data is becoming more spread out, which is causing our curve to become wider itself. And then lastly, if we increase it even further to 190, you can see that peak gets much smaller, right? Our data is much more spread out because our standard deviation has increased, right? Our variance has increased, so the variability of our data is increasing, which makes it more spread out. And again, these are all still considered normal distributions, but they look very different, right? With their different standard deviations. Okay, so the last thing I want to talk about in this video is something called the empirical rule, which states that 68% of your data will lie within one standard deviation below and above your mean. So we can see here, this normal distribution, it has a mean of 0, right? Because 0 is under the peak. It's at the center of our bell curve, which is what we often times will refer to normal distributions as. We'll call this a bell curve. Right, so 68% of your data will lie between 1 standard deviation below and above your mean. 95% of your data lies below the curve between 2 standard deviations below and 2 standard deviations above. And lastly, 99.7% of your data lies between 3 standard deviations above and 3 standard deviations below. And so remember, note that's 99.7%. It's almost all of it, right? You still have a little bit of your data left out here in this tail beyond 3 standard deviations below, and a little bit left in this upper tail, right? 3 standard deviations past 3 standard deviations above. So this rule we'll use to answer questions in the next video, and we'll see how we can apply it.